Okay, back for part 2. So the first part of this is you can imagine some very complicated math. I wouldn't even know how to figure out all the little the lengths of the curve and how that would be calculated. The main thing is, where can we find that information? Now, I've taught a similar approach using Maya, and it has a little mel command. It's kind of like its little embedded API, and you can just type a command. You can just say arc length, which is like, what's the length of this curve? It will give me a number. So I had to go looking a little bit. There were some complicated scripts out there, but actually there's this hidden little place where you can figure out what the length of the curve is, right? So if I click on the ball maze and I go up to edit and project info, I have no idea why it would work this way, but it does, right? So I clicked on the object, I went to edit project info, and I have an object selected. I go to the selection, it has oops, why does it not, let me go there. There we go. So I have it selected. Let's do edit project info there, right? So it says that, hey, I have this object selected. It tells me how many points are in there, that it's a line segment. It has no textures or anything, but it has a structure. And lo and behold, deep in this little attributes tab for this object, when only accessing it through the edit project info menu structure, do I find out that the spline is 572.463. So I'm going to put that in the annotation because that's important, right? So 572.463. 572.463, right? Okay, and I'll just say this is length, just so I remind myself, and to help you on, all out there with the tutorial. Path length. Probably doesn't need an exclamation mark. Path length, right? So it's in here. Okay, so that's the first part. We also need to figure out what the circumference of the ball is. Again, remember that analogy. If this path is like a string that I would wrap around the circumference, I need to figure out how many times it is. Well, I need to figure out what that circumference is, because I can't pick this up like a string, right? So this is where that formula. So the math for the circumference of the ball, right, is, maybe you've heard this one, pi r squared, right? So what's the radius squared times pi? So the ball itself, because I used it, I haven't done the make edit command, right? It's still a parametric sphere. So the radius is 4, so I'm just going to double that, so that would be 8, and then I would multiply that times pi. So I'll just use my little spotlight thing as my calculator, 3.14 times 8. So 25.12. Okay, so this is the circumference of the ball. So let's put that in an annotation, 25.12. Ball oops. CIR? I don't even know how to spell it now that I think about it. Okay, I'm just going to put that there. Circumference. Is it really like that? I don't even know. Maybe that's wrong. There's no spell check in annotation on Cinema 4D, by the way. It doesn't matter. We're doing math. We don't care about spelling at this point. Okay, so I have those two components, right? So now what I need to do is figure out how many times would one complete revolution, how many revolutions does it take to get to 572, right? So if one revolution would travel 25.12 centimeters in this case, how many times does it have to revolve to get 572.463 centimeters down the road, right? So what we're going to do is just divide those. So let's take 572. Right, you know, let's get serious. Let's use our calculator. So 572.463 divided by 25.12. Right? 22.789. Let's put that down. Okay, so what does that number mean, right? So this is how many times, so if 25 is one complete rotation, right? And then we divide that in here. So this would be how many rotations it has to do to get to the end of the curve. It needs to rotate 22.789 times, right? Number, of complete rotations. All right, and of course, what is a rotation when I'm talking about a sphere? Because I have to animate this, right? So I have to multiply this by degrees. So back to the calculator. So let's multiply that by 360. So 8,204.08. 8,204.08 total rotation. Okay, look at that. So I basically created a cheat sheet with my my little note card, my little annotation on the sphere itself, and I've arrived at the math that tells me here's how much rotation has to happen with my object when I get to the very end. So before I start doing any animating, I did Command D, and I'm just gonna say, let's use 24 frames per second, and I'm gonna make this long, so I have plenty of time for this to rotate without having to, go the speed of light to go from the very beginning to the end. So we'll give it a little bit of time. The other thing too, I think I'll do is, since the grid grows in here, let's wait till frame 60 to start it rotating for whatever reason, right? Maybe the ball's just hanging out and it's confused by this maze that has grown up around it, and then it starts at frame 60. So let's do the animating along the path first, and then we'll do the direction of it, and then we'll do the rotation. So let's go to the rectangle, and at frame 60, let's go ahead and say be 0% of the way along the curve. And then, I don't know, let's go to frame 400, I guess. No, let's, let's just do 400. Nice round number. Okay, and then we'll tell it to move all the way down there, right? 100% of the way. And I will say, I will put a keyframe there, right? And we see that we have that working. All right, so that is moving along there. So we'll go back to frame 60, for whatever reason I chose that. So let's go to the sphere. So now what we need to do is figure out which one of its, sphere itself. So when it's rotating in its coordinates, I'm just gonna do a little cheat here so I can see it's actually rotating on the negative. It depends on how you drew the curve and its direction. There's some other things that you might want to think about. Depends on how you draw the curve. At the direction of that. So in this case, because it's just a sphere, it doesn't really matter. Other times what you might need to do is put one more level of like a null object so that you can change the orientation of the rotation, something that I covered in a previous tutorial for one of my classes. So, but in this case, this will not matter. I just need to know that it's rotating in the right direction. It would go in the negative. So actually that 8,204.08, when we get here at frame 60, so let's just say, at first it's going to be 0 rotation, and by the time we get to frame 400, it is the magic number, minus 8,204.08. I'll put that in there. Okay, so let's see how that's working. And it's a little, and I'm anticipating this is going to be close, but it's not going to look quite right. See how it seems to slow down in the curves, and then it's definitely off at the very end here. So why would that be? So there's a couple things. So let's click on the ball maze path. And when we created this object, we did it as a B-spline. And then Cinema 4D always has this intermediate points. And the intermediate points is basically in this method is it says, let's add more points where there's more curvature, right? Where there's more detail and based on the angle, right? So it says if this, depending on what kind of change in the degree of the curve itself, or the line, right? It adds more points. And where the points are distributed along here affects the speed that this aligned to path or aligned to spline tag works. So the easiest way to deal with this is just to say, you know what? Don't use a random, it's not really random, right? But don't use an uneven distribution that's based on detail. Just use a totally even distribution across the whole entire thing. And just here's the number of points I want you to add in between these other points. And if I need to, I can up those, right? So I could say, because it's a big curve, I can have more detail in these little sections. But this part, and there's other ways you could approach this, how you would draw the curve, but uniform, it's nice and consistent, and I'll just up the number of points. But what we should see here is something, it's still probably not going to be perfect, but it's going to be closer, right? Already that looks 10 times better, right? Where it's very plausible. Okay. So there are a couple things to think about depending on what you, how you want this to happen, right? The ball is starts out slow at the beginning, just because Cinema 4D's default, right, is to make these ease in, ease out curves. So it did that for the curve tag position from 0 to 100%, right? It starts out slow and it gets to a constant rate of speed, and as it gets towards the end, it slows down. The rotation is doing the same thing. If you decide you want it to not slow down, or you want it to start or stop fast, however you want to do that, keep in mind that you have to make sure that modifications that you may make to that F curve, in fact, let's look at those, right? And let's turn off the auto, and let's load this little buddy and this one here. And let's go to F curves. So you can see, I see this here, and with the sphere rotation, let's do H. So the same thing here, it's easing in and easing out. So if I were to change, you know, how this is happening down here so that it comes to an abrupt stop, I would want to make sure that I do the same thing to the position tag itself. Okay. So I'm going to leave it there with that. That's getting close to my little cutoff of around 15 minutes. The one thing is I've turned on the shading with the line so I can see the wireframe on top of this. So in the animation itself, you would want to put some kind of, I'm assuming, you would probably want to put some kind of texture on it. It could be a stripe around the middle, so you could use a ramp, you know, a gradient. You could put checkerboard. So maybe, you know what, let's just do that just for fun, really quick, easy. Well, we leave it here. Let's do material. Let's create a new material, I don't know, PBR. And I'll put that on the sphere, and I'll double click. Let's reflectance model. Let's go into diffuse. Let's give it a texture and surface checkerboard. And you can see the checkers on there. Actually, that looks like way too many checkers. I'll turn off the, let's just go straight crowd shading. And, oops, I meant to click on this one, checkerboard. And let's tell the frequency to just be 4x4 or something, right? So we don't get as many checkers on there. So this is just, I'm not sure checkerboard would be the way I would go. I would probably do a gradient, like a stripe around the middle, but you could put a decal on it, whatever you're gonna do. But that's maybe for another tutorial, right? And I'm doing this just with the standard cinema material. You could do this with Redshift, and maybe I'll do future tutorials about maybe some render lighting, everything. So let us recap. Math is our friend. When the math is really complicated, there's usually a utility will give us the answer, right? So this told us how long the path was. We had to do a little bit of math, but we already knew what the radius was, right? And we already know that pi is 3.14. Once we figure that out, we divide into the total and we figure out some rotation. And now we have something that's plausible, right? That looks correct. We turn on a little motion blur. It's going to look really nice. Okay, so there you go. Happy animating.